Topic 6.2, solving equations using algebra. We can solve an equation using algebra. To help us visualize the equation, we can think about a model such as balance scales or algebra tiles. Isolate the variable, and don't forget about the golden rule of algebra, which is whatever you do to one side, you've got to do to the other. Otherwise, the equation is no longer true. Now let's try a few examples. Take number 1. 3b plus 5 is equal to 14. First thing we want to do is isolate the variable term. In this case, it's 3b. So if we wanted to visualize using a model, algebra tiles, we would have 3 variable tiles. We'd have 5 positive tiles, and on the right-hand side of the equal sign, we'd have 14 positives. And then we'd want to remove this 5, do the same thing on the other side, and then divide the remaining portion on this side by the number of variable tiles. What does that look like using algebra? Just regular numbers and symbols? Well, it looks like this. So there are actually 2 ways you can show it. 3b plus 5 minus 5 is equal to 14 minus 5. Okay, what we're doing here is we're actually subtracting 5 from positive 5 so that we can delete it, so that we can get rid of it. And we're subtracting 5 from the 14 because we are following the golden rule of algebra. What we do to one side, we've got to do to the other. Otherwise, it's imbalanced. So 14 minus 5 is going to leave us with 3b is equal to 9. Okay? Now, what we're left with is what we call a coefficient. A coefficient is a number that is multiplied by the variable. What you can do is divide by the coefficient to get one of them. All right, if you think about this, 3 divided by 3 is 1. So 3b divided by 3 is simply b, which is what we want to find out. What we do to one side, we have to do to the other, remember. That's the golden rule of algebra. So because we divided by 3 on this side, we have to divide on the other. 9 divided by 3 is 3, and we have b is equal to 3 as an answer. Now it's always a good thing to verify that your answer is correct, and you can do that using the substitution method. We're saying that b is equal to 3, so let's plug in the number 3 in place of the b in the original equation, and then see if the equation makes sense. So if we're right, 3 times 3 plus 5 should equal 14. 9 plus 5 is equal to 14. That is true, right? 9 plus 5 is equal to 14. So it looks like we're right. How about the next problem? 13 minus 2x is equal to 5. And we solve this problem the same way. We want to isolate the variable term in this case, negative 2x. And then we're going to be dividing by the coefficient, this negative 2 here, to determine what x is. So remember I said that there were 2 ways to show this. One was horizontally like this. I'm going to show you the other way. To get rid of this 13, we can simply subtract 13. It's a positive 13, so if you visualize this using algebra tiles, this would be 13 black tiles, and we want to make 13 red tiles, cancel those ones out. So that's what we're doing here. That gives us 0. Now what we do to one side, we've got to do to the other. That's the golden rule. Don't forget it. Otherwise, the equation is imbalanced. 5 minus 13 is going to be negative 8. So what we can do is we can rewrite this equation now as negative 2x is equal to negative 8. We're left with a coefficient of negative 2, and we can divide by that, including this sign here. Don't forget to include that, okay? Negative 2 divided by negative 2 is going to leave us with 1x, right? Or just simply x. And what we do to one side, we do to the other. So negative 2 over here, dividing by negative 2, that is. Negative 8 divided by negative 2 would be 4. So x is equal to 4. Or 1x is equal to 4. Now, get into the habit of checking to make sure that you're right. Verify that you're right. If we are correct here, then we should be able to plug this number, 4, into this equation and find that it's perfectly balanced. So let's do that to make sure we've done it right. 13 minus 2 times 4 is 5. Now we'd be multiplying first, right? Bed mass. Multiplication comes before subtraction. So 13 minus 8 is equal to 5. It looks good to me. What do you think? And the last example, 18 is equal to negative 4x plus 2. So once again, let's isolate the variable term. So let's subtract this 2 over here. Okay? Get rid of this so that we're left with just negative 4x. We subtracted 2 over here to get rid of positive 2. We've got to do the same on the other side. So that's going to be 16. We can rewrite this equation now as 16 over here on this side is equal to negative 4x over here on this side. And what we'd like to do at this point is divide by the coefficient, which is negative 4. Divide by negative 4. Divide by negative 4. On this side, we're going to be left with x. On this side, we're going to be left with negative 4. So we're saying that x is negative 4. So let's just make sure we've done that right. We haven't made any mistakes. Take the original equation, 18 is equal to negative 4. We can substitute what we're saying x is for the letter x up here. So that's what we'll do, negative 4. And that will be, then we'll be adding positive 2. So now, let's see if we're right. 18, so multiplication is going to come first. That's going to be 16 plus 2. Remember, a negative times a negative is going to give us a positive. That looks like a true statement. So we're right. Topic 6.3, solving equations involving fractions. Equations involving fractions cannot be easily modeled with algebra tiles or balance scales. We can write and solve these equations, though, using algebra. Let's have a look at a few examples. Take number 1. N divided by 4 is equal to 5. Remember that division and multiplication are actually just inverse operations. So if we can divide n by 4 and get 5, then we should be able to multiply 5 times 4 to get n, just by thinking backwards. So in order to solve a problem like this, we can simply multiply these two numbers together. 5 times 4 is 20, so n is equal to 20. And we can always just quickly check to make sure that that's accurate. If n is equal to 20, 20 divided by 4 should equal 5. And it does. How about question number 2? 15 is equal to 100 divided by p. Well, using the same logic, if we are going to divide the number 150 by p, and we can get 15, how can we rearrange this equation so that what the answer is p? Well, with any division statement, you can actually swap these two values for one another. So if we know that 150 divided by p is equal to 15, we also know that 150 divided by 15 will equal p. So we're just doing the opposite with these two numbers. Okay, so 150 divided by 15 would be 10. So p is equal to 10. We would simply divide this number by this number. Now, example 3 and 4 are very similar problems, except there is some extra value on one of the sides of the equation. So we have to go back to our original plan to isolate the variable term. In this case, the variable term is a fraction. Okay? So we want to, in this example, remove the 3 over here. Get rid of the 3. Do the same on the other side. Rewrite the equation. Negative 3 is equal to now, don't forget about this negative sign. We have to account for it. Negative n, over 9. Okay, now we're left with an equation very similar to this one. So the relationship between these two numbers is such that if we multiply them together, it will equal the value on top here. So if we do that, we have negative 27. 9 times negative 3 is negative 27. And that's going to be equal to negative n. Again, just be careful to account for this negative sign here. Now, we know what negative n is, but we're interested in what n is. We want to know what n is. Now, if there's a negative in front of the variable, you can imagine that it is a negative 1 in front of the variable term. Okay? And if that's the case, in order to get rid of it, you have to divide by the coefficient, which in this case is negative 1. So we'll be dividing by negative 1 to be left over with n. And remember, what we do to one side, we have to do to the other. So divide by negative 1, and we'll have 27 on this side. And now for our last example. P divided by negative 3 plus 9 is equal to 3. We want to get this variable term isolated. So we'll subtract 9 on this side. Subtract 9 on this side. That's what we did over here. So we've got to do the same on this side. That will leave us with negative 6. So let's rewrite the equation. P over negative 3 is equal to negative 6. Okay? And then we can simply multiply these two numbers, remembering the relationship between these two values, and we will get P is equal to 18.